Hello students, today we're going to take a little bit of introduction on classifying polygons, getting to know a couple of the properties. Please make sure as you go to take notes and complete the survey that follows this video. So in order to identify polygons, we need to know what they are. So definition, our polygons are a closed figure that lies on a plane with the following properties. The first property is that it's formed of 3 or more line segments, and we call those sides. And the second one is that each side intersects exactly 2 sides. One at each endpoint, so that no 2 sides with a common endpoint are collinear. Continue with that, those endpoints in which 2 sides come together at, it's called a vertex. If I were to say multiple vertex, we call it vertices. And then we can name a polygon by listing the letters in consecutive order, each of the vertices. Okay, so just kind of looking at the polygon on the right here. Again, we have to have 3 or more because 2 sides cannot be closed, so we can see that we have no openings here. And then each side intersects has 2. So what that means is we only have 2, so 1 and 2 coming in at each vertex. So the way I'm going to name this would be something like A, B, C, D, E. So this is polygon A, B, C, D, E. As you can see, I picked a letter to start at, and I went in consecutive order. In this case, I went clockwise. I could go counterclockwise. I could start at a different letter if I choose to do so. However, we can't just jump around. You can't say E and then jump to D and then go to C, B, and then E. This is something that we cannot do. Okay, so we have to pick a letter and then clockwise or counterclockwise as long as they're consecutive order. And that's how we name our polygon. Continuing on, there's 2 different types of polygons as well that we can have. The first is a convex. This is a polygon in which no line that contains sides of the polygon contains a point in the interior of the polygon. So this is an example of a convex polygon. What it means is there's no points that are going inwards. All the angles are pointing outwards. So the opposite of this would be a concave. And the key thing here is the word cave. Think of like caving in. So a polygon that is not convex is known as concave. And this is an example of a concave. So the previous one talked about interior of the polygon. That's an example where there is a point that's inside or on the interior of our polygon. The angle is essentially caving in. And if we were to calculate this angle, we would focus on the angle, and it would go out in this direction here. We would not be looking at the interior one there. So let's take a look at a couple of examples to determine whether it's a polygon or not, and if it's convex or concave. Starting with letter A, this is the piece that points out to me right here. And as you can see, if we would look at this point right here, we have 1, 2, and 3 lines coming together. So based upon that, this guy here is not a polygon since we have more than 2 segments intersecting. In letter B, I'm looking at all of my vertices, and I see I only have 2 points together. So there, and I have all line segments. And then I look at, are they outside or inside? I don't have anything on the interior of our polygon, so this is a convex polygon. Looking at letter C here, this is what's standing out to me as being different. I have myself a curved portion here, which means it is not a segment. It's not a line segment. It's curved. So because of that, it's not a polygon. And then finally in D, I see I have 1, 2, 3, and 4 points that are on the interior. It is a polygon since it's only meeting in every vertex. We only have 2 lines or 2 sides meeting up at each vertex. But since it's going inwards, you have a point inside. We have a concave polygon. Classifying polygons by the number of sides. So I want you to create a chart. We probably are familiar with 3 sides. If we have 3 sides, we know that it is called a triangle. If we increase it to 4 sides, now we have ourselves a quadrilateral. The words tri and quad should stand out to you. Tri meaning 3 and quad meaning 4. Things you may or may not know, 5 is a pentagon, and then 6 is a hexagon. Now I expect you to know actually all these here, 3, 4, 5, and 6. You should be familiar with octagon and decagon and dodecagon. The heptagon and the nonagon are not so well known, so it's okay if you tend to forget. But the other ones you should be familiar with. Anything more than 12 sides or even 11 sides, we can use something called the n-gon. So for example, if it had 17 sides, you can call it a 17-gon. So when we do that, we represent it by the letter n. So again, that represents the number of sides that our polygon can have. Finally, we're talking about regular polygons. We know 2 things. What an equilateral polygon is a polygon that has all equal sides. You may have heard of equilateral triangle. So equilateral polygon is extending beyond just triangles. The other type is equiangular. So again, we have this equi, meaning the same, and then lateral versus angular. So this means we have equal angles in here. So a polygon that has all equal angles. If we have a combination of being equilateral and equiangular, we have ourselves a regular polygon. Again, this has to be a convex polygon that's both equilateral and equiangular. Just to kind of give you an idea on what it would look like, we have ourselves all the tick marks here on each of those sides, and within our angles, we have ourselves the arches that would indicate that we have equal angles. So if it's not indicated in the directions that we have ourselves regular polygons, or I don't tell you, and it has all that, you can assume by all these markings. If you have any questions, please make sure you write them down. If not, make sure you can, or you can enter them in the survey and complete the survey that follows this video. See you tomorrow.